Hello and welcome to this session, Building Secure IoT Solutions with Azure Sphere and IoT Hub. My name is Dave Glover. I'm a cloud developer advocate based in Sydney, Australia, with a focus on the Internet of Things. Today we'll also be joined by Mike Hall, who's based in the UK, and he's a principal software engineer lead in the Azure Sphere team. Alrighty, so just in terms of a very high level view of what a typical application architecture is for an IoT solution. So fundamentally, you've got things generate data. In this case, the thing is going to be an Azure Sphere. We're going to be building insights based on that data that's generated from the telemetry that's been sent from the Azure Sphere, and we're going to generate actions based on insights. Now, the flow of this session is going to be pretty much, we're going to talk about things, then we're going to talk about insights, and then we're going to talk about actions. Okay, so Mike, handing over to you. Mike's going to talk a bit about Azure Sphere.
Okay, thanks. Okay, so let's talk about Azure Sphere. When we think about building IoT solutions, there are a number of different parts to it, one of which is the hardware. So for example, this is an Azure Sphere development board that has on it the MediaTek MT3620 chip. And we think about capabilities of that IoT system. Most IoT systems are fixed function, meaning that the hardware that the device is going to talk to is known upfront and doesn't change. And the endpoints that the device is going to talk to are also well known upfront and don't change. So for example, the application that we're building today for secure IoT and IoT Hub, we know the sensor that we're going to be using, we know the endpoints we're going to be talking to, and those don't change. And that's part of the security story of building a secure Azure Sphere system. So all up, the system contains three parts: the hardware, and that is obviously the Azure Sphere chip, and also the external hardware that you're going to be using on your device, the operating system that runs on the Azure Sphere chip, and also cloud security. Now, there are a couple of interesting aspects to this. The first of which is when we think about secure IoT, there are really two parts to this. The first of which is building new and interesting devices that live in the IoT realm. So for example, I'm holding up a two-wheel self-balancing hard real-time robot based on Azure Sphere, custom hardware, but shows the real-time capabilities of Azure Sphere and Azure RTOS. But you may also think about using Azure Sphere as a way of securing existing hardware that maybe isn't secure, and you wouldn't by default connect directly to the internet. So the cloud security system that is shown in this diagram is responsible for ensuring that devices are up to date. That includes the operating system running on the device, as well as the applications that you write that can be deployed over the air to devices in the field. So in terms of security, you should really think about security in a number of different domains. In fact, there's an article, a paper that's been written called The 7 Properties of Highly Secure Devices. And the 7 properties are listed here. We're not going to spend time on that in this session. There's a link at the bottom of the page, aka.ms/7 properties. If you're considering building a secure IoT system, go read that paper and then compare the security of the system that you are going to be building against those 7 properties. And obviously, Azure Sphere complies to the 7 properties. Dave,
Alrighty,
back to you.
Thanks, Mike. Now, I seem to remember you were going to do a quick demo for us, just showing us about how some of this, how the security works on the device. So perhaps you could just walk us through a very simple example of showing how the device already is locked down by default. So I see you're bringing up Visual Studio there. So perhaps you just talk us through that demo.
Sure. Yes, of course. So one of the things I just mentioned was that for the devices that you're building, IoT devices, they're typically fixed function. The hardware that you're using is known up front. The capabilities of the system, the endpoints that you're going to be talking to in the cloud are all known up front. So what I've got here is a sample application that comes from the Azure Sphere samples GitHub repo, the Hello World. In the IoT world, the typical example of Hello World is turning an LED on and off. So how do you turn an LED on and off? First of all, you open something called a GPIO, general purpose IO, and this could either be opened as output, so you set the value high or low, or as input, so you're reading the value to find out whether it is high or low. So in our case, we're opening as output, and then in this loop down here, we're setting the value low and high, which will toggle the LED on the board. If you can see the board here, it's the LED at the bottom right-hand corner of the board that will toggle on and off. So I've got the application ready to go. I'm just going to deploy the application. And I've got a breakpoint set here in Visual Studio. And I'm using Visual Studio 2019 here, but I could just as easily use Visual Studio Code. I'm using Windows, but using Visual Studio Code, I could also be developing on Linux as well. Okay, so the application is deploying. Once deployed, the breakpoint will hit, and then we'll single step that line of code. Okay, so we're now getting to the point that the application is starting. We're starting to see diagnostics, memory tracking here. The breakpoint has been set inside of the application. So now what I'm going to do is just single step F10, single step that line of code, check the file descriptor FFF, that's -1. That means that we failed to open that GPIO, which means we can't set its value. The application cannot change that value. So why is that? The other file that I've got open as part of this project is the application manifest. And the manifest contains a number of details, including the name of the application, a GUID that uniquely identifies that application, as well as a number of capabilities. GPIO is listed, but I2C, SPI, PWM, analog, and allowed endpoints, cloud endpoints, are also part of this capability list. So for now, this GPIO list is empty. My application could use multiple GPIOs. What I'm going to do is just paste in the value for the sample LED that we're using in this application, which basically says, I want my application to be able to use that LED. Right, let's come back to our application code. Build and deploy that application. The same breakpoint is set. So when the application is fully deployed, we'll hit that breakpoint. Again, we'll single step over that line of code, check the file descriptor, ensure that it's not -1. If I had allowed the application to run last time round, we would have seen an error. Error, can't open the GPIO, and the application would have exited. So in our case, the application is updated to allow access to that GPIO, and the breakpoint is now set or hit, F10, single step, check the value of the file descriptor, value is 4. It's great to have these data tips available to see these kind of values. And now I'm just going to let the application run. And if you have a look bottom right-hand side of the camera view, you should see the red LED now flashing on and off once per second, the standard blinky Hello World application. So Dave, over to you, and you can talk about extending this into
Mike, I just
IoT
want to
Hub.
add something in here. You've actually built what's called a high-level application. And I think also
Yes.
the important thing about that is you're actually building really a Linux application or a POSIX compliant application. So you'll start seeing things like file descriptors, and you'll start seeing those concepts. So if you're built on Linux, you'll know those. And often it's a really useful technique if you're building an application to often actually model things on a Linux-based system. That could be in WSL on Windows or maybe on your desktop Linux system. The beauty of that is you can be building things which are based on threads, for example, or file descriptors, and you can model a lot of that code on your desktop and then move that across into your IoT application on Azure Sphere, which certainly from my experience can really help speed up some of the time to development. Is that a fair summary, Mike?
Yeah, I think that's fine. Yeah, I'd add one thing. You talk about high level. There are also real-time capable applications as well. In our case, we're just running a single app on the A7 core or high-level core for this Blinky application. The robot that I'm holding up now is using not only the high-level application, but it's also using Azure RTOS on one of the real-time cores for the real-time control of the system.
Okay, that's cool. And from my understanding, is that the beauty of that is that you've got two dedicated cores on the Azure Sphere, which are running these real-time applications, and they can actually communicate with a high-level application as well and swap data in between those two applications. So that's awesome. Thanks, Mike. Okay, so the next thing we're going to do is swap across to look at one of the samples that you'll find in the Microsoft Learning module for Azure Sphere and IoT Hub. And I'm just going to go through very quickly what that application would look like. So like Mike was doing, I'm building a high-level application. And you can see if you built C applications before, you've got the standard kinds of things for it includes. And what I'm going to do is just copy and paste a bit of this application in here and just going to give you a sense of how this application hangs together. So with that, I'm going to add in what we call device timers, event timers. Now, event timers are really the kind of the recommended way in which you go and build an application. If you think about an IT application, often what you're wanting to do is you're often wanting to do things on a periodic basis. So like every 4 seconds, for example, in this example, I'm going to measure the CO2 sensor. It happens to be that every 4 seconds, I'm also going to be publishing the telemetry. But of course, they could be running at different cadences. But you also might have a timer there, which might be looking at the status of a button. Has a button been pressed or something like that? So timers and event timers are a key kind of concept for Azure Sphere and one of the kind of really recommended best practices. If you have come from the world like of Arduino, where you were used to using things like delay, don't do that. Really think about your application as being timer event driven is really the kind of the paradigm we recommend for Azure Sphere applications. Okay, the next thing we're going to be adding in is device twins. Now, a device twin is a JSON document that is held up on the cloud for each device that connects to your IoT Hub. And what I'm going to here is I'm going to set a couple of properties inside the JSON document that's sitting up on IoT Hub. You can see one which is called desired CO2 alert level, and the other one's going to be called reported CO2 level. So in fact, this first device twin is actually a device twin that's really coming from the cloud down to the device. And what that's going to do, it's going to set a threshold. And once that CO2 goes above that threshold, then it'll start the beeper. But we also want to be able to do a reported CO2 level. And this is kind of useful because what it does is it represents a point in time in the cloud of the state of that device. And it means that you can go and query that data in the cloud for your cloud-side applications. Okay, the next thing we're going to do is add in what are called application properties. Now, again, recommend these as kind of a best practice. Think of application is like metadata. It's data about the data. So in this case here, what I'm going to do is add some application properties, and I'm going to define effectively 3 key value pairs. I'm defining an app ID, and the value for that is going to be CO2 monitor. And the value of that is that when that data gets up into the cloud with that bit of metadata, I can start making decisions based on that metadata as to where I want to route that data. Maybe I want to route it into storage, event hubs, into a database, or things like that. I often recommend that you also include a schema and a schema version because, as we all know, schemas do change. And if you include a schema version inside your application, then that just makes it much simpler for folk that are making decisions in the cloud. Do they need to transform that data or normalize that data or do things like that? So really invaluable to have application properties defining some additional metadata about each message that's going up to the cloud, up to IoT Hub. Okay, the next thing I recommend is that you add in what are called system properties. Now, the 2 that we're adding in are really around content, which define content encoding. In this case here, we've got UTF-8 and the content type application/JSON. Now, again, I recommend you do this because with this metadata attached to the message, again, it makes it easier for cloud-based processes to automatically make decisions on the type of data that is flowing up from your device. In this case, what we're going to be doing is sending up a JSON packet. Okay, so we've defined our timers, we've defined a device twin, message properties, and system properties. The next thing I'm going to do is put in some handlers. So the first handler I'm going to add in is called the measure sensor handler. Now you see this function here, the C function is called measure sensor handler. And if I just pop up here to this timer, so you see I've got this timer, and this timer is going to fire every 4 seconds, and it's going to call this C function called measure sensor handler. And not too many surprises. Its role is every 4 seconds, it's going to call this function, which is going to read the sensor and read in the CO2 levels. Okay, so the next thing we're going to do is going to add in one more function. And what this is going to do, so this publish telemetry handler, if I just scroll back up to my timers, you can see I've got this timer up here called publish telemetry timer, and the handler for that is publish telemetry handler. And that will fire every 4 seconds, And what that's going to do is ultimately going to call this function here called Azure Message Send with properties. So what it's going to do is going to send the JSON message. So you can see up here I've got a snprintf, which to go and build the JSON packet. I'm going to attach to that message the metadata, so the telemetry properties. Remember, that's things like app ID equals CO2, the schema was 1, and remember I'm adding in the content properties. So in this case, I'm saying the encoding is going to be UTF-8, and I'm using formatting as JSON format. So we'll send that message up, and that's kind of how you do that. And then the last thing I'm going to do every 4 seconds is I'm going to set the state of the device twin in the cloud and for this device. So you can see I'm going to be setting the report CO2 level. And if I just scroll back up here to the device twin definition, remember that the device twin that's going to impact or update inside IoT Hub is going to be called reported CO2 level. Okay, so that's pretty much the anatomy of the app. And as I said, when you go through the Microsoft Learning module for this Azure Sphere and IoT Hub, it's very much this pattern. You go and declare timers, you go and declare device twins, application properties and things like that, and then you'll start sending messages. And then just scroll down to the bottom here, you'll see again a standard pattern for Azure Sphere applications is a function there called init peripherals, GPI, and handlers. And there you can see I'm obviously doing all the initialization for the app, and the same principle there applies for closing. And then in the main entry point to the application, this loop here is really just going to loop when an event fires, and that will call the appropriate handler. And when I've done that, obviously, just like Mike did before, I would go and deploy this application, build the application, and deploy that across onto the device. Obviously, in my app manifest, I've defined I'm using an I2C device, so I've had to define that, and I've had to define the entry point, the endpoints for IoT Hub. I'm also using what's called the device provisioning service, and I'm also using some geolocation endpoints. So that'll load up. Alrighty, so back to the slides. So we've had the demo of, you saw that, hopefully you got a bit of an idea about the security. So remember, Azure Sphere applications are secure by default. You can have high-level applications, which are really, kind of think about them as Linux-based applications or POSIX-compliant applications. And you can go and build real-time applications. And we also need to, really declare all the resources you want to go and use, be it endpoints or GPIO, SPI, I2C, etc. Okay, so the next part of this talk is going to be looking at really the cloud side of this data processing or this IoT architecture. So we're going to look at the insights which are based on the data which are coming from the Azure Sphere. Okay, so there are two kind of fundamental services that live in Azure for processing of data or for managing data coming upstream from a device. I'm actually going to start on the right-hand side and talk about something which is really a helper service for IoT Hub. And that is called the device provisioning service. And really about what that's about is it's about simplifying the mass deployment of devices. What you don't want to be doing is putting things like connection strings into each device, because that rapidly becomes really unmanageable. So device provisioning is all about managing and automating that whole process of initiating a connection from the device. It's kind of through the device provisioning service and then ultimately across into IoT Hub. It's kind of like the middleman in terms of providing those services. But it also does a lot of other things as well. For example, load balancing. You might need multiple IoT hubs spread around the globe, and you can use various algorithms to say, look, I want this device to be connected to this IoT hub and kind of manage that process. Okay, so the next thing I want to talk about is IoT Hub. Now, IoT Hub is a bidirectional communication engine. And think about it, it's around internet scale messaging engine, and it deals with literally billions of devices. It supports multiple protocols, HTTPS, AMQPS, MQTTS. It's there for supporting for devices sending messages obviously from the device, but also be able to send messages to the device or commands for that matter, or be able to send device twin messages down to device to go and set the state, and also manage that whole process when a device updates a device twin that gets pushed up into IoT Hub, and then IoT Hub will manage that whole process of updating the device twin for that device. Obviously, security is paramount to this whole process, and IoT Hub there will manage things like device certificates, TLS security, X509 support. Also, very importantly, the ability to be able to enable and disable devices per device. You may have a rogue device that you need to go and disable. Maybe for whatever reason it's got out of calibration, for example, and you need to go and disable it to have somebody actually go and look at that. So it's super important for these types of scenarios here to be able to look at and be able to manage all those devices. Okay, so that I want to talk about in a little bit more detail a kind of a couple of the key things inside IoT Hub as opposed to over and above what I've already mentioned. So the first thing I want to talk about is this thing called Azure IoT Message Enrichment. Now we had, and you saw those devices you saw the device there, we had the telemetry that was coming off that device we had temperature, humidity, and CO2. You remember that we also had application properties. So we had app ID as CO2 monitor, we had type was telemetry, format JSON, version 1 is schema, and things like that. So what you can do is you can use what are called the tag section inside a device twin. Now a tag section can be really useful to enrich the data as it's flowing through. So for example, when you go and deploy that application or deploy that device, when you deploy that device, you won't really know its location. Yes, you can do things like have the device send a geolocation of where it's at, but often what you wanted to do is as part of that provisioning system, you say, okay, I provision that device, I have the ID for that device, now I'm going to build a back-end application, and what that's going to do is that's going to update these tags with things like the device name. In this case here, I've called it Sydney Factory. And I've also been quite specific about the longitude and latitude. Now, as messages flow up through the device, through IoT Hub, you can see that has been enriched. And we basically augmented that message now with additional information that we're providing up in the cloud. And obviously that starts to make it more useful, that data more useful for upstream processes. So maybe Power BI reporting, for example, would be, you might want to go and do geomapping. And longitude and latitude can be really handy to have that information to be able to, or critical to have that information, as well as things like the name, a friendly name for the device. The other thing that you want to be able to do is what's called message routing and partitioning. Now, you really use these where you've got a limited number of IoT hubs, which are often being able to support a number of different applications. So in this case here, we've got a CO2 application we're monitoring, but also you might have other devices which are monitoring security systems, lighting systems, heating systems, and things like that. And it doesn't really make sense to have an IoT hub for each one of those applications. So what you want to be able to do is make routing decisions as that data comes through. And that's why it's really important to have these application properties or this metadata on these messages, because you start making sensible routing decisions on that data. And you can see here what I'm about to do is I've got rules-based routing. In this case, it's an HVAC system. And you can say, look, I've got various endpoints, and for the HVAC system, I'm going to be sending that off to an event hub. And you might have a security system, and the app ID for that might be security. And you know then to go and route that message off to the security system, or maybe it's in a security alert system that you've got high priority messages and things like that. Same deal there for lighting systems. And also often what you want to be able to do is log all data, and what we call that into cold path. And it's typically cheap storage. Where you might just need it for audit purposes or logging. You want all the data that comes through into that system to be held, and often in storage, in blob storage. So again, a really useful way of being able to do that and automate that whole process and make smart decisions. But the recommendation is that you really think about, if you're a device developer, you think about making sure that you're adding a metadata into those messages that you're sending up to the cloud, because then it makes the process of being able to manage that data and process that data in the cloud much simpler. And to kind of give you an idea, the other thing that you often need to be able to do is stream processing. And we've kind of got the whole concept here of the data that's now being routed into these various endpoints. You remember I had them going into the HVAC system, security system, lighting systems. And then invariably what you want to be able to do is stream processing. And there are various types of stream processing, and it really depends on the type of organization you are in terms of the processes. But what we tend to see inside organizations is that you'll either be using something like Stream Analytics or Databricks or Azure Functions. Now, the reason you might want to do stream processing is often you've got a lot of data flowing up into the system, and it's often more than you need. You might need all that data for logging purposes, but when it comes to stream processing, you might want to aggregate that data. For example, you might actually be more interested in that data as the average value over a 10-minute period, for example. That's really enough for your reporting. And obviously, if you start aggregating your data, that potentially makes your data storage costs more cost effective as well. So the approaches to stream processing really come down to the kind of organization. If you're a more database-centric organization, with a lot of database skills, then the general recommendation, probably the direction you'll go, is something called stream analytics. It's very SQL-centric. If you do T-SQL inside Microsoft SQL Server, for example, you will understand how to go and build stream analytics. If you're more of a data science organization, then a lot of organizations will go and use things like Databricks. If you've already got those skills, then you can use Databricks and the stream processing side there. If you're more of a developer-centric organization, then things like Azure Functions can be a really useful way of doing that whole stream processing aggregation. But of course, if you're using things like Azure Functions, you're really hand coding that yourself, and of course, that's code you've got to manage and maintain. So the advantage of stream analytics is very declarative, very SQL-like, but it's very much you choose the one that really makes sense inside your organization. And then really you need to find the endpoints for this. So again, you might be pushing this data out into cold storage. You might be wanting to push that data into Azure SQL, for example, and you might want to use Power BI and things like direct query against that SQL backend data source. But also you might want to go and put it into data warehousing, Azure Synapse. You might want to push that data into Databricks. You might be wanting to go and generate a machine learning model that you might ultimately want to push down onto the Azure Sphere, for example. And the example that Mike's going to show in a moment is in this case here, we've got the data flowing through the system into an event grid and into a logic app. And in this case here, we perhaps want to send a message back to the device and say, hey, look, you need to, your CO2 levels have got too high, and there's a warning for that. So Mike, we'll hand over to you now, Mike, and perhaps if you give us an example of building this application.
Sure, thanks. Okay, so what we see on my screen at the moment is Visual Studio 2019. I'm running the same application that Dave was showing a few seconds ago, and we've also got the camera view looking at my device with a sensor. Now, one thing to point out is the sensor has got a CO2 sensor on it, as well as temperature and humidity. So what we're seeing in the telemetry inside of Visual Studio at the moment is CO2, temperature, humidity, and so on. The CO2 level is currently at 1272, roughly 1272. Okay, I'm going to move the camera view out the way because we don't actually need that for the rest of the demo. And I'm going to bring up initially the Azure IoT Explorer. So what this gives me the ability to do is look at telemetry as it's flowing into IoT Hub from devices. So we can see the messages from my device, and the device ID shown at the top of the screen here is contained within this JSON blob. So we can see the CO2, temperature, humidity, and so on. And all of this is contained in this section called body. Now it's interesting to note that because we'll come back to that in just a second. So in the JSON is body and CO2, temperature, and so on. Okay, so in IoT Hub, Dave talked about a number of paths that you can use using routing to get your data to various places. One of the things you might want to do based on a certain event that has occurred is maybe send an alert to a particular person or team or something, so that a condition on a particular device or devices can be dealt with rapidly. So inside of IoT Hub, we've got this thing called events, and this is the linkage from IoT Hub into Event Grid. And what we can see is that I have created an event handler inside of the Events tab called Build Demo, which has an endpoint of webhook. Now, for Event Grid, there are 5 different event types you can deal with. Device created, device deleted, and so on, and telemetry. Telemetry is the item that we're interested in, and that is shown as event types Microsoft devices, device telemetry. Now, one of the things that I can do by default is, if this is all I did, then all telemetry events from all of my devices coming into IoT Hub would be sent to my webhook. And that's probably not what we need. You probably want to filter based on certain capabilities. So one of the things that Dave was talking about was message routing. And what we can see at the bottom of our routing table is route to event grid. And if I open that up, this gives us the ability to, in effect, set up a rule that says, if this rule is true based on my incoming device data, then send the message, in our case, to a webhook. And note that it is $body, remember that from IoT Explorer, .co2 is greater than 2000, then fire the webhook. And the webhook is just an HTTP REST post endpoint that either you can create, perhaps using ASP.NET Core or Azure Functions, or some predefined webhook endpoint, such as a Logic app. Now, there's one thing to bear in mind. If you're connecting to Event Grid and Event Grid is firing to a webhook, the first thing that Event Grid is going to do is send a registration JSON message to you. And in order for you to validate against Event Grid, you need to extract the registration value and send that back to Event Grid. Okay, so that's setting up Event Grid. Now what we're going to do is take a look at the Logic app that is connected. So this is the HTTP REST endpoint, the webhook that our IoT Hub is talking to. Okay, click on Edit. One of the great things about creating Logic apps, of course, is that it's kind of drag drop. You don't really have to do any coding here at all. So what this is saying is, when an HTTP request is received, here's the endpoint URL, and that URL is in the IoT Hub Event Grid setup. So for each message that arrives, and that's based on that filter, that route. In our case, we're saying not all messages will come through to this Logic app, but only if the CO2 level is greater than 2000, then fire to this webhook. Interestingly, in IoT Hub, the routing, if I just remove this $body.co2 greater than 2000, just replace that with true, then all messages would flow through to this Logic app that we've created. So what we're saying is, we'll take the body and then we'll post a message into a Teams channel, and we'll extract from that body temperature. So we'll say the temperature is, so many degrees Celsius, and the CO2 level is CO2 and the device ID. We could also pull out other attributes of the JSON message, for example, the lat-long location or other information that is useful. Okay, so that's how the pieces are tied together. Now let me bring up Teams, and you'll notice that I've posted a message into the channel that basically says, we're not going to see any messages here until the CO2 level is greater than 2000. And in the background, in Visual Studio, we can see the telemetry still being generated, and see that the CO2 level is roughly 1200. So what I'm going to do is just move away from the camera for a second and blow on the sensor, which will then hopefully force the CO2 value to be above 2000. Okay, there we go. I've blown on the sensor. We can see CO2 values of roughly 1400. There we go. Now we see 2944 and messages appearing in Teams. So there we go. What we've shown is, inside of IoT Hub, connecting an event to Event Grid, and then using Event Grid to route messages to a webhook or an HTTP post endpoint, which in our case is a Logic app, which then filters data and posts that to a Teams channel. Dave, back to you.
That's awesome, Mike. What I love about that is really it's very much a low-code solution as well. You've really pretty much had to drag and drop and define a few properties, and you've actually got the beginnings of a business solution there based on the application. So really just kind of summarizing this talk. So remember, we started off with things. We talked about secure IoT with Azure Sphere devices. We've got our cloud gateway, so Azure IoT Hub. We talked about security. We talked about message enrichment, message routing, stream processing, different ways in which you can go and store the data. for insights. And then in terms of actions, Mike just showed a great example there of using event grids with logic apps and with Teams to be able to get notified saying, hey, maybe your working environment is not optimal for your concentration levels and things like that. Or you could go and use things like Power BI. Alrighty, so that's this session. So thank you very much for joining us. So these are the resources for the session here. So you'll find the link there to the learning module. So do check that out. You'll learn all about Azure Sphere in more detail and how to work and connect that with IoT Hub. There's a link there to Azure Sphere as well. So check out that. You'll find all the documentation up there. And you'll find information up there on IoT Hub as well. So take a screenshot of those links. And this is the link off to the Microsoft Learn module. So develop secure IT solutions for Azure Sphere with IoT Hub.